Hello, this is not your chem tutor, and in this video, I will teach you how to solve the molar mass or the molecular weight of compounds. A lot of problems in chemistry involve molar mass, so this is an important skill to learn. I have included a lot of examples in this video so you can practice the calculations. So let's proceed right away to example 1. Compute the molecular weight of sodium phosphate or Na3PO4. The very first step you need to do is to list all the elements present in the compound. So we have sodium, we have phosphorus, and oxygen. The next step is to count the number of atoms of each element in the compound. So we have 3 sodium, we have 1 phosphorus. When the element has no subscript, it is assumed that the subscript is 1. And we have 4 oxygens. Next step is to multiply the number of atoms to the atomic weight of the element. So I have also given here the atomic weights of Na, P, and O. If it is not given in the problem, you can look for the atomic weight using your periodic table. So it's written in the periodic table. So for sodium, that's 3 times 22.99 grams per mole. For phosphorus, that's 1 times 30.97 grams per mole. And for oxygen, that's 4 times 16 grams per mole. And you solve this using your calculator. For sodium, this is equal to 68.97 grams per mole. For phosphorus, this is 30.97 grams per mole. And for oxygen, this is 64 grams per mole. And then you get the total. So 68.97 plus 30.97 plus 64, this is equal to 163.94 grams per mole. This is the molecular weight of sodium phosphate, and this is the answer to the question. Example 2, compute the molar mass of CH3COOH or acetic acid. So the elements in the compound are carbon, hydrogen, and oxygen. For carbon, we have 1 plus 1, 2 carbons. For hydrogen, we have 3 plus 1, so 4 hydrogens. And for oxygen, we have 1 plus 1, 2 oxygens. So let's multiply the atomic weight. 2 times 12.01 for carbon, 4 times 1.008 for hydrogen, and 2 times 16 for oxygen. And then solve this using your calculator. For carbon, this is equal to 24.02. For hydrogen, this is equal to 4.032, and for oxygen, 32. And you get the total, 24.02 plus 4.032 plus 32, this is equal to 60.052 grams per mole. So this is the molar mass of the compound. For example 3, compute the molar mass of aluminum sulfate or Al2SO43. The elements are aluminum, sulfur, and oxygen. There are 2 aluminum atoms. For sulfur, the subscript is 1. When an element is inside a parenthesis, you will multiply the subscript of the element to the number outside the parenthesis. So for sulfur, we have 1 times 3, that is equal to 3 sulfur atoms. For oxygen, we have 4 times 3, that's equal to 12 oxygen atoms. So for aluminum, 2 times 26.98. For sulfur, 3 times 32.07. And for oxygen, 12 times 16. For aluminum, that's 53.96. For sulfur, this is 96.21. And for oxygen, this is 192. And you get the total, 53.96 plus 96.21 plus 192. The molar mass is 342.17 grams per mole. And this is the answer to the question. For our last example, compute the molecular weight of potassium aluminum sulfate dodecahydrate or KAlSO4212H2O. When you see this type of chemical formula, this is the chemical formula of what we call hydrates. So a hydrate is a compound that contains water molecules in it. So for example, this one contains 12 water molecules. So how do you calculate the molecular weight of a hydrate? You can first calculate this portion. So KAlSO42. So what are the elements? We have potassium, aluminum, sulfur, and oxygen. So we have 1 potassium, we have 1 aluminum, we have 1 times 2, that's 2 for sulfur, and for oxygen, 4 times 2, that's 8. So let's multiply the atomic weights. For potassium, 39.10. For aluminum, 26.98. For sulfur, 32.07. And for oxygen, 16. Solve this using your calculator. For potassium, that's 39.10. For aluminum, that's 26.98. For sulfur, that's 64.14. And for oxygen, that's 128 grams per mole. If you add everything, 39.10 plus 26.98 plus 64.14 plus 128, this is equal to 258.22 grams per mole. So that is the molecular weight of this portion of the compound. Then solve the molecular weight of water. So H2O. So the 2 elements are hydrogen and oxygen. 2 hydrogens and 1 oxygen. So hydrogen, the atomic weight is 1.008. And for oxygen, that's 16. For hydrogen, that's equal to 2.016 grams per mole. And for oxygen, that's 16 grams per mole. And when you add that, that's 18.016 grams per mole. According to the chemical formula, there are 12 molecules of water. So you will multiply the molecular weight of water by 12. So 18.016 times 12, that is 216.192 grams per mole. And the final step is to add 258.22 grams per mole and 216.192 grams per mole. So let me just write that. 258.22 grams per mole plus 216.192 grams per mole. The total is equal to 474.412 grams per mole. So the molecular weight is 474.412 grams per mole.